Okay, let's get this started. So, today I'm going to go through the exam one. Nothing crazy. So yeah, this will be like my work solutions, I guess. So let's get into it. So first few questions, just like usual, we've got some nice and simple diff. First one here is going to be our product rule. So with this sort of thing, I'll write it all out, but we should be able to do this pretty quickly. So I'll call the x squared f of x. I'll call the cos x a g of x. So I know that f dash of x is going to equal 2x. I'm going to know that g dash of x is equal to negative sine x. Since we know the product rule is going to be f dash x gx plus g dash x f of x, that tells us that we're going to end up having 2x cos x plus, or rather minus, we'll have f of x times g dash of x, so x squared times sine x. And there we go. Next one, f of x equals that. Find the gradient of the tangent at x is 8. So the goal here is basically just f dash of 8. So from there, we just have to figure out what the derivative is. That's just chain rule. So we lower the power by 1, so we're going to have 6 times x plus 1 to the negative half. Take the power out the front, so that's times by a half. 5 obviously disappears. Multiply by the derivative of the inside, which is just 1, so we can leave it at that. So that's going to be 3 times 1 on root x plus 1. From there, we sub in 8, so f dash of 8, and that's going to equal 3 on root 9, so that's going to equal 1. That's it for 2 marks. Next one, we got some antidiff, just like usual. So g of x is a function when x is bigger than negative 3 on 2, so g dash of x is that. So goal is here, find g of x, so all we're going to do is integrate this, because integrating g dash of x with respect to x gets you back to regular g of x plus c. And to find the plus c, all we're going to do is use this idea that when x is 1, y is 0. So when we have g of x, or g dash of x rather, being 1 on 2x plus 3, when we integrate that, that's going to end up giving us a natural log. It's going to be half log e 2x plus 3. Reason why is we have the power being minus 1, so that means it's going to turn into a log. Then we divide by the derivative of the inside, which is 2. And then I'll have a plus c. So from there, I know that that's my g of x. So from there, if I need g, I get told g of 1, 0. So that's going to equal half log e 2 plus 3 plus c. So that tells us that my c value is going to be half log e5, or negative half log e5. So from there, I can then say that g of x is going to be equal to half log e 2x plus 3 minus half log e5. If you really want to, you can then divide, because the coefficients here are the same. So I can say half log e 2x plus 3 on 5. You don't need to do this though. This statement here is completely fine. Let's keep moving. Okay, so state the range of f. This is just a circular function. So we know that it's going to be revolving around the translation, which is 1 unit up, and it's going to be going up and down by the amplitude, which is 2. So the range is going to be 1 minus 2 to 1 plus 2, which will be equal to minus 1 and 3. From there, solve f of x equals 0. That's basic circular functions. We've seen this hopefully since like year 10 or 11. So let this be 0. From there, we can also transform our domain. So we know that x is an element of 0 to 2 pi, which then tells us that 2x is an element of 0 to 4 pi. So when looking for our first set of solutions, we can look within this domain as well. So before rearranging, I'm just going to do that. Negative half equals cos of 2x. That tells us that I'm going to be in quadrants 2 and 3, where cos is negative, and my reference angle is going to be equal to pi on 3. From there, I'm just going to look at angles that are going to work between 0 and 4 pi, and I'm going to equate that to 2x. So that's going to be 2 pi on 3 in the second quadrant, 4 pi on 3 in the third. Do it again to add 2 pi to these solutions, so that'll be 8 pi on 3 and 10 pi on 3. Divided by 2, so you get pi on 3, 2 pi on 3, 4 pi on 3, what's going on there? And 5 pi on 3. Once again, that's really it. We have this graph here, so we have to be careful about this domain. It's from pi on 2 to 3 pi on 2, which is a bit weird. So I'm just going to draw some points that are going to be on the regular unrestricted graph, and from there it sort of helps me draw the real graph, and I'll just erase what's not necessary. So our function is 2 cos 2x plus 1. I'll just write that down. So we know then that we're going to have a point that exists around here. Our period's going to be pi, so another point will be here. Another one will be over here. So I'll plot a couple points there. This is going to be our range that we need, or our domain that's needed. And if we were to draw the regular graph, it would look something like that. So thinking about that, we can then plot some more points in at 1. I'm really going to butcher this because I hate drawing on an iPad. You're going to get something like that on one side, and something like that on the other. And we found the coordinates earlier for the x-intercepts. That's pi on 3 and 2 pi on 3. So make sure they're coordinates. And that looks really bad. That's wrong because it's 4 pi on 3 and 2 pi on 3. Because we should kind of tell that pi on 3 is not bigger than pi on 2. And so label the endpoints, and so that's going to be 3 pi on 2 minus 1, pi on 2 minus 1. I'll also label the stationary point just to be safe. That's going to be pi 3. And that's really all you have to do, nothing crazy. My shape's kind of wonky, but who really cares? Next, we have this distribution, show that k is either 10 or 15. So the main rule here is that we need to show that the total probability here sums to 1. So with that being said, I'm just going to write down all the stuff here. So we're going to have 4 on k plus 2k on 75 plus k on 75 plus 2 on k equals 1. It is a show that as well, so I'm going to show all my steps. I'm going to collect my like terms, so I'm going to have 6 on k plus, whoa, there's a mosquito, plus 3k on 75 equals 1. I can simplify the 3k, so I'm going to have 6 on k plus k on 25 equals 1. I'm then going to make sure everything has the same denominator, so I'm going to have 25 times 6 is 150, plus k squared on 25k equals 25k on 25k. I can get rid of the denominator here, so I'm going to have k squared plus 150 equals 25k. So k squared minus 25k plus 150 equals 0. I can kind of cheat here and use, I'm going to know that these factorize to 10 and 15. And so we can just double check that, but it should check out. 10 plus 15 is 25, so it's all good. So I can say k minus 10, k minus 15 equals 0. Therefore, k equals 10 or 15. Let k equals 15, find the probability x is bigger than 1. So that's the same thing as 1 minus the probability x is 0. Because that's going to be, minus probability x is 0 plus, or minus the probability x is 1. Because if we're not including 1, that's just these cases here. I can just do x is 2 plus x is 3. But I've decided to make it more complicated for myself. So that's going to be 1 minus 4 on 15 minus 30 on 75. From there we can simplify, so we'll have 1 minus 4 on 15 minus, what's that, divided by 5, so you'd have 6 on 15, yeah, so that's going to be 1 minus 10 on 15, so that's going to be 5 on 15, or a third. Find EX, your expected value, so that's going to be your x times px sort of idea. So it's going to equal 2k on 15, or not 15, 75 plus 2k on 75 plus 6 on k. Just multiplying everything here. And we also know that k is equal to 15. So I'll just try to give them that. And from there we'll sub it in, so it's going to equal 30 on 75 plus 30 on 75 plus 6 on 15. So instead of 30 on 75 was 6 on 15. So that's going to be 6 on 15 times 3, so because there's 3 of them, so 18 on 15 is your final answer. I should just write EX.
Just one thing to note with this in post, I should have simplified that. That should be 6 on 5.
Cool. Solve this. Okay, just let e to the x equal a or something. So therefore we can say that a squared minus 8a plus 7 is 0. So we have a minus 7, a minus 1 equals 0. Is that right? Yeah, okay, cool. So I'm going to have a equals 7, a equals 1. So therefore we have e to the x equals 7, e to the x equals 1. So x is going to be either log e7 or 0. Let g of x be that. Let g of x have exactly one stationary point being a local minimum. Find the largest value of a such that when g is restricted, it has an inverse function. So all we have to do is figure out what a is, where we know that a is going to be the local minimum, because for this function to have an inverse, it has to be 1 to 1, and so if the domain restriction has to be 1 to 1, and it's going to stop being 1 to 1 when it's beyond the minimum. So all we'll do is just differentiate this and solve for where the stationary point is. So I'll have g dash of x, it's going to equal 0, and the derivative is going to be 2e to the 2x minus 8e to the x. I can then just start solving. I'll say b equal e to the x. So then we're going to have equals 2b squared minus 8b. I can factorize, so I got 2b, b minus 4. So b is either 0 or 4. So that means we have e to the x equals 0 or e to the x equals 4. We're going to reject this first case because e to the x is always bigger than 0. But with x being equal, with e to the x equaling 4, we can say that x is going to be log e4. And so this is the point of the local minimum, and so hence a is going to be log e4. Cool. Let's keep moving. Find variance of x for a binomial. That's just np1 minus p. So we know the n's 6, p is 1 on 4, so that's going to be 6 on 4 times by 1 minus p, so that's going to be 3 on 4. So that's going to be 18 on 16, which would end up giving us, that's not a delta, that's an 18, that's a 9 on 8. Determine the probability x is bigger than 5. So that's just probability x is 5 plus probability x is 6. So with that being said, we can just use the regular binomial formula. So we'll have 6 choose 5, 1 quarter to the 5, 3 quarters to the 1, plus 6 choose 6, 1 quarter to the 6, 3 quarters to the 0. A lot of this stuff doesn't just cancels out because it's all equal to 1, and I'll show you what I mean. 6 choose 5 is equal to 6. Then we'll end up having 1 quarter to the 5 times 3 quarters to the 1. So that's just going to end up giving you 3 on 4 to the 6. Because it will just be 1 times 3, and there's going to be 4 to the 5 times 4 to the 1 on the denominator. So that's really it there. On the right hand side, 6 to the 6 is 1. 3 to the 4 to the 0 is just 1. So we just have 1/4 to the 6 here, or 1 on 4 to the 6. So from there, we can then say it's going to be equal to 18 on 4 to the power 6 plus 1 on 4 to the power 6. That just adds nicely. So it's going to be 19 on 4 to the 6. And that's in the right form. No, it's not. It's not base 2. So I'm going to rewrite that. It's going to be 19 on 2 squared to the 6. So it'll be 19 on 2 to the 12. There we go. Next, verify x is 5 as a solution. All we're going to do here is sub in x is 5 and make sure it's equal to 0. Equals 0 if x equals 5 is a solution. So f of 5 would be 125 minus 25 minus 80 minus 20. So that's going to be 100 if we look at the first two terms, minus 100 if you look at the second or last two terms. So that's going to be 0. And so therefore, x equals 5 is the solution. Express f of x in this form, we'll just do some long division. So with that being said, we can say f of x, or I'll just start doing long division honestly. So we'll have x minus 5, x cubed minus x squared minus 16x minus 20. I have a pretty good idea what d is going to be, but we'll see what happens. So we'll have x squared, so minus x cubed minus 2x to the 5. That's going to give us 0 and 2x to the 5. So that's going to, what's 2x to the 5 doing there? 2x squared rather. And that's going to be x squared minus 16x minus 20. So that'll give us plus x minus x squared minus 5x. That should be a 5. What am I doing? Let me fix this. I don't know what the hell I'm doing. Now that's 4x squared, so we'll have plus 4x here, minus 4x squared minus 20x. And that's going to give you 5x. Is that right? Yeah, 5 or 4x minus 20. And so that's going to give you plus 4. Yeah, okay, my guess was right. Minus 4x minus 20. And so that's going to give you 0. So therefore, f of x is equal to x minus 5, x squared plus 4x plus 4. And that's going to be x plus 2 all squared. So that's it. Next, this is f of x. Cool. So if we know that we have our function f of x in the form of x minus 5 x plus 2 all squared, that tells us that this point here is going to be minus 2. We have a stationary point on the x-axis at minus 2. The other x-intercept will be 5. For the y-intercept, you can just look at the constant value at the end of the expanded form. And that's just going to be minus 20. So that's your answer there. Next, g of x is x plus 2. State the coordinates of the stationary point of inflection for the graph of fx gx. Okay. So, if we have f of x gx, fx gx would be equal to x minus 5, x plus 2, all squared times x plus 2. Which would mean we'd have x minus 5 and then x plus 2 all cubed. And since we have this cube section here, that tells us we have a SPOI when x is minus 2. And it's going to be on the x-axis still, so therefore we'll say the SPOI will be at minus 2, 0. Write down the values of x for which f of x gx is bigger than 0. You can just draw this out, I guess. So f of x gx is going to be a polynomial of degree 4. It's positive, so it's going to kind of look like that in that sort of footprint. We know this got x-intercepts at minus 2, the SPOI, and then we'll have the one at 5. Don't really care what the y values are, but that's your graph basically. I can get rid of this blue section now. From there, this is minus 2, this is 5. So we need it to be bigger than 0, so that's going to be this section here and this section here. So that means x is going to be between minus infinity, and I'm going to say it's all real values, honestly, and then I'll just exclude some sections. So that's going to be from minus 2 to 5. I'm not going to include 2 and 5 within my exclusion because they are included because we have f of x and f of x gx being bigger than or equal to 0. So these points are still included. I don't want to get rid of them, so I'm not going to include them in my exclusion. You could also say just minus infinity to minus 2 union 5 to infinity. Nothing wrong with that, but it's a good idea to understand how both work. Let's keep moving. Consider this function. Find k such that the probability x is bigger than k is 9 on 16. So that tells us that if we have probability x is bigger than k is 9 on 16, that means the integral from k to the upper bound, being 4 on 3, of our function 3 on 8, 4 minus 3x, with respect to x, is equal to 9 on 16. So from here, it's just a lot of solving. So I'm going to take the 3 on 8 out of there. Reason why is I can use this to cancel with the 9 on 16. So I can divide both sides by 3. So I'm going to have 1 on... I can divide by 3 on 8, really. So I'm just going to have 4 on 3 to k, 4 minus 3x with respect to x. And then from there, my 9 turns into a 3, my 16 will turn into a 2. Okay. So from there, we can then integrate. So we have 4x minus 3x squared on 2 with bounds k and 4 on 3. Then we'll just sub it all in. So we have 16 on 3 minus 3 times 16 on 9 on 2. That's from subbing in 4 on 3. We sub in k as well, so you get 4k minus 3k squared on 2. So let's start simplifying. So we got 16 on 3 minus, we'll have 16 on 3 on 2, so that's going to be 16 on 6. Can this delete, please? Minus 4k plus 3k squared on 2 equals 3 on 2. From there, we know that 16 on 6 is the same thing as 8 on 3. So that's going to be 16 on 3 minus 8 on 3, still 8 on 3. Minus 3 on 2 plus 3k squared on 2 minus 4k is equal to 0. Then we can start cleaning this up, and it's now just going to basically be a quadratic. So I can rewrite these constant terms. That's going to be 16 plus minus 9 rather on 6 plus, I'll make everything with a base 6, so that will be times by 3, so 9k squared minus 24k on 6. So we're going to have 9k squared minus 24k plus, what's that, 16 minus 9, that's going to be 7 equals 0. Hopefully I've done that right. Yep. So from there we'll have 9k, and then we'll have we'll have a 7 somewhere. What can we do? I presume it'll be that. That's minus 7. That wouldn't work. Let's try 3 and 3 maybe. Would that work? You'd have... Yes, this should be right, because then you'd have 3k, 21, that's 24. Yep, perfect. So that means we're going to have 3k equals either a third, or k equals a third rather, or 7 on 3. Looking at our domain, x is between 0 and 4 on 3, so k's got to be a third. 7 on 3 is beyond our domain. I'll just say k is element of 0, 4 on 3. So k equals 1/3 only. Cool. Next, transformation hx is a transformation of f of x such that that happens. Find that integral. Cool. So I can say that the integral of h of x with respect to x is going to equal the integral of mfx plus n dx, obviously. I can then just do some splitting up, so I'm going to have integral of mf of x dx plus integral of n with respect to x. So I can take the m out the front as well, because that's a constant. And then integral of n stays there. From there, we can chuck in the bounds, so 0 to 4 on 3, h of x would be m 0 and 4 on 3 of f of x plus 0 to 4 on 3 n dx. That should be dx, not dn. Cool. From there, we know that the integral of f of x from 0 to 4 on 3 is going to equal 1, because it's a probability function. The area under this function should be equal to 1. So I'm going to have this bit equaling just m. I'm going to have to integrate n like it's a constant, so that's going to be nx between 0 and 4 on 3. You're going to get 4 on 3n. And that's your final answer. Next, consider these functions. If w is minus 3, find 4 solutions. Okay, cool. So we'll have f of x equals 9 on x minus 1 all squared. We'll have g of x equaling x plus 3 all squared. So f of x equals gx, so I have 9 equals x minus 1 all squared equals x plus 3 all squared. This sort of question, you can really waste a bunch of time if you don't do this the right way. Do it the right way, rather. So you got to be real careful here. So 9 equals x plus 3 all squared, x minus 1 all squared. From here, we can just square root both sides. So we'll just say plus minus 3. You just have to make one side plus minus. Then we have x plus 3, x minus 1. And so from there, we can start looking at cases. So I'll just say case 1. We have x plus 3, x minus 1 equals 3. So the positive version. So that means we'll have x squared minus, that'll be plus 2x minus 3 equals 3. So that means we're going to have x squared plus 2x minus 6 equals 0. Is that right? I think so. Yeah, checks out. So from there we can just do a bit of completing the square. That'll be x plus 1 all squared plus 7. Oh, is that right? Or minus 7 rather, equals 0. So you have x plus 1 equaling plus minus root 7. So x equals minus 1 plus minus root 7. Case 2 is when we have it equal to minus 3. So x plus 3, x minus 1 equals minus 3. So we'd have x squared plus 2x minus 3 equals minus 3. We can just cancel them out. So you have x squared plus 2x is 0. Factorize. So you have x being 0 or x equaling minus 2. So therefore the 4 solutions are minus 1 minus root 7, minus 1 plus root 7, 0 and minus 2. Cool. Next, consider the case where w is bigger than 0. Find in terms of w the coordinates at the minimum point of this graph. So the minimum of this graph here is going to be just negative b on 2a. That's one way of looking at it. It's also just going to be halfway in between the x-intercepts. And so we know the x-intercepts are at 1 and w. So we can then say that x is going to be 1 plus w on 2. That's really it. You can expand it out and do negative b on 2a, but I presume you get the same answer from that. From there, we can sub the x value in to get the y values. So y of 1 plus w That's going to equal 1 plus w on 2 minus 1. 1 plus w on 2 minus w. Cool. So then that's going to get us 1 plus w minus 2 on 2. So that's minus 1. And then we'll have 1 plus w minus 2w. So that's 1 minus w. From there we can expand. So that's going to be minus 1 plus w times by the negative minus 1 minus w on 4 basically, or plus rather. So from there, that tells us it's going to be negative w minus 1 all squared on 4. I'll keep it at that. I'm not going to expand it. Just keeps it nice and simple. So therefore the coordinates, or the coordinate rather, or the coordinates is going to be 1 plus w on 2, and then minus w minus 1 all squared on 4. Next, hence or otherwise, find the positive values of w for which this has exactly 3 solutions. F of x equals gx has exactly 3 solutions. So we have w squared on, what was it, x minus 1 all squared? And that's going to equal x minus w all squared. Cool, so from there, w squared equals x minus w all squared, x minus 1 all squared. So with this, we can sort of draw it out. And so we have a general idea as to what this thing could look like. It's going to be a quartic, it's going to be positive, there's going to be 2 x-intercepts. They're both positive because we know that w was positive. So from there, we're going to have, I might just reshape this. So we're going to have a function that looks something like that. Let's say w is bigger than 1. Might not be, but let's say this is 1 and this is w. And so we need this f of x equals gx to have 3 solutions. So that means we're going to have w squared being this thing here. That's the only time when we have 3 solutions. If you have it below this, you're going to have 4 solutions. If you have it above it, you'll only have 2. If you have it exactly here, you'd have 1. So with this, what we have to do is figure out where this stationary point is, and just figure out what the y value is, and make sure that's equal to w squared. So to find a stationary point, all we'll do is just differentiate. And so we know there's going to be x is 1 and w, so we can kind of eliminate them and just figure out what the other one is. So I'm just going to diff this real quick. So we're going to have, we can just use a bit of product rule, I guess. So d dx x minus w all squared x minus 1 all squared is going to equal, we should know how the product rule works. If not, refer back to the first question. So that's going to be 2 x minus w x minus 1 all squared plus, then we'd have 2 x minus 1 x minus w all squared. And this thing's going to equal 0. So from there we can factorize nicely. So biggest factor here is going to be 2 x minus w x minus 1. And then the other factors are going to be x minus 1 plus x minus w. And so this is nice because these other solutions are stuff we already have and we don't need. So we just say x is w1, not needed. Then we're also going to have 0 equals 2x minus 1 minus w. So I can then say that w plus 1 on 2 equals 0.
Yeah, me again. I don't know what the hell I was saying. This shouldn't be 0. This should be x.
But what we do know is at when x is 1 plus w on 2, the y value of x minus 1 x minus w is that. So from there, we can sub that into this thing. And so we have x minus w x minus 1 given x is equal to w plus 1 on 2 is going to equal minus w plus 1 all squared on 4. But notice that this thing is just this, but squared. So I'm just going to square this final answer. And so that's just going to be w minus 1 to the 4 on 16. And so this thing has to equal w squared. So that's what the y value of this thing is. From there, it's just a matter of solving. So I can then square root both sides. So I get plus minus w equals w minus 1 squared on 4. So that's just what I had from earlier. And I'll just do the two cases again. I presume there's going to be one that's going to get rejected, but that's fine. Better be safe than sorry. So we have w equals w minus 1 all squared. Actually, the other case won't work because this thing's already positive. It won't give solutions. So we can just do 4w equals w minus 1 all squared. We can expand, so w minus 2w plus 1, that's 4w. So 0 equals w squared minus 6w plus 1. So why am I not writing my squares? So w is going to equal, that doesn't factorize. Well, we can just complete the square. So we say 0 is w minus 3 all squared, that's going to be plus 9, so minus 8. So we have 2 root plus minus 2 root 2 equals w minus 3. So 3 plus minus 2 root 2 equals w. We have w being positive as well. And 2 root 2, is that bigger than 3? If that was bigger than 3, we have 2 root 9 on 4, I think. Yeah. And 9 on 4 is bigger than 2. So that's fine. This is cool. So yeah, this makes these two answers are still positive. They're still both bigger than 0. You can chuck it in your CAS to check, even though it's tech free. And so those are going to be your values. That's really it. And that's the end of the exam. So yeah, pump that out in 40 odd minutes. This is probably going to be shorter in post after I cut everything up. But there you go. That's really it. So if I'm being honest, not many big separator questions on this exam. Nothing sort of diabolically difficult. A lot of annoying quadratics and that sort of stuff, and easy stuff to sort of mess up. But in terms of really difficult questions, there really wasn't much. There's a lot of questions where if you don't do it the right way, you can definitely waste a lot of time. Especially these quadratics and questions like this binomial sort of probability question and stuff like stuff like this and this sort of question here where if you didn't square root both sides, you sort of be wasting a lot of time there. But that's really it with this exam. If you have any questions with this exam at all, please feel free to type in the comments or whatever. Shoot me a message. I'm more than happy to help out there if I can still read those comments and get the notifications. If you ever need some more methods help, you're more than welcome to shoot me a message or a comment, and I'm more than happy to be a tutor as well. So yeah, that's really it there. All the best for your exam prep and all that sort of stuff. Yeah, cool. See ya.